All right, so let's have a look at number 2 here. So it says using the expansions of cos 3x minus x and cos 3x plus x, prove that half cos 2x minus cos 4x is identical to sine 3x sine x. Well, we know that I'm going to start off with the left-hand side here, as is generally the good thing to do when questions of proving right-hand side equals left-hand side. So I would start with the side that looks more complicated and you can do more things with. Now, if I start off with the left-hand side here, well, I'm going to start off with half cos 2x minus cos 4x. But we've been asked to use the expansions of on the line above. So now I'm going to write cos 2x as cos 3x minus x minus cos 3x plus x. And slowly I'm going to build this up. So using the addition rule here, we get cos 3x cos x plus sine 3x sine x minus, and I'm going to put this in brackets just so that I don't make a mistake with multiplying out negative and positive terms, cos 3x cos x minus sine 3x sine x. And so if I expand this minus 1 inside the second bracket, I get cos 3x cos x plus sine 3x sine x minus cos 3x cos x plus sine 3x sine x. And at this stage, we can see that this term here cancels out with this term. And we get a half times 2 lots of sine 3x sine x. And so now if I multiply the half in, the half is going to cancel with the 2. And that is equal to the right-hand side. And therefore it is the end of the proof. So we've done part 1 of this question. Let's have a look at the second part. So we've been asked to integrate sine 3x sine x between the limits of pi over 3 and pi over 6 and show that it is equal to. So let's have a look at how am I going to do this question. So first of all, this is very key when it says hence. We're going to use, generally whenever we see the word hence, we're going to use an earlier part to answer this one. So we can use some of the results we've acquired in an earlier part to answer this. So we've got pi over 3 over here at the top and pi over 6. We've got sine 3x sine x dx. We need to show that it equals 1 over 8 root 3. Well, what we realized in part I was that sine 3x sine x is identical to half cos 2x minus 4x. Now the benefit of writing it as a sum of those cos ratios is that we can actually integrate it, whereas if we tried integrating sine 3x sine x using either by parts or by substitution, we would we would get stuck at some stage. So now what we can do is write sine 3x sine x as a half, open brackets, cos 2x minus cos 4x dx between the limits of a third pi and a sixth pi. So now I like taking constants out just so that I don't get confused when I've got constants like cos 2x in there. And hopefully now it should be fairly straightforward to integrate. The integral of cos ax is 1 over a sine ax. So we get half, open square brackets now because we're actually going to integrate. So we're going to get 1 over 2 sine 2x minus 1 over 4 sine 4x between the limits of pi over 3 and pi over 6. So I'm going to leave that half alone. I'm going to multiply right at the end stage. If I substitute pi over 3 in there, I get a half sine 2 pi over 3 minus a quarter sine 4 pi over 3. Take away, now I've got to substitute pi over 6 in there. And here I'm looking at a half sine 2 pi over 6 minus a quarter sine 4 pi over 6. At this stage, I'm going to use my calculator to work this out. I need to make sure my calculator is in radian mode. So I'm going to change the angle unit to radians. And I'm going to do one bracket at a time. I don't like putting the whole thing in there. And actually what I do like doing is storing the input as alpha. So for example, I'm going to write the fraction, I'm going to write pi over 3, and I'm going to store that in A. And you're going to see the benefit of why I've done that in a second. So now I'm going to do the first bracket, i.e. this thing here. I'm going to work that out on the calculator so you can see exactly how I type it in. So we get 1 over 2 times by sine, and because it was 2x, I'm going to type in 2 alpha a minus, and this is 1 over 4 times by 4 alpha a. Not 1 over 4, 4 alpha a, sine 4 alpha a. So when I work that out, I get 3 root 3 over 8. Oops, I'm just going to change the color here. Not forgetting the half. So the problem with taking the half out is sometimes you might forget about that. So what did we have? 3 root 3 over 8 for the first bracket minus, now the benefit of storing in alpha a is that if I now store pi over 6 in alpha a, I can simply go up and press equals again. If I scroll up and press equals, that will give me the value for pi over 6 in there now, substituted in. So we get root 3 over 8. And so now what I can do is say 0.5 times by open brackets fractions 3 root 8 over 8 minus root 3 over 8. Well, I write that as actually fraction first, root 3 over 8, close brackets. I don't get what I want, so that's brilliant. Let's have a look at this. Where's this gone wrong? Have I gone wrong anywhere here? 1 over 2, 1 over 4, pi over 3 and pi over 6. And that looks fine.